Hello everyone, welcome back to the channel. In today's video, we're going to explore one of the most frequently asked topics in Python interviews, string operations. Strings are a fundamental part of Python and mastering string manipulation is crucial for cracking interview questions. We'll dive into practical examples that cover common string operations like reversing strings, checking for palindromes, slicing, and more. These questions test not only your understanding of strings but also your ability to use Python's built-in methods efficiently. So, if you're prepping for interviews or just want to sharpen your skills, you're in the right place. String operations in Python are all about working with text data efficiently, and Python gives you a lot of built-in methods to make it easy. Think of strings as sequences of characters, and even though they're immutable, meaning you can't change them directly, you can still manipulate them in a variety of ways. For instance, you can concatenate strings, which is just a fancy word for joining them together, like putting hello and world together to get hello world. You can also slice strings to extract specific parts. If you want the first 5 characters of hello world, you just use slicing to grab hello. Searching within a string is super simple too. You can check if a substring exists by using in. So if you want to know if word is in hello world, Python will give you a nice true or false. There's also case conversion, which is really helpful for making sure your text is in the format you want, whether it's all uppercase or lowercase. And of course, if you want to change part of a string, you can easily replace a word or character. For example, you can replace world with Python and turn hello world into hello Python. All of these operations are straightforward and really useful when working with text in Python. Now that we've covered the basics of string operations, let's dive into some practical examples. These examples will show you how to apply the concepts we just talked about, like concatenation, slicing, and replacing parts of a string in real world scenarios. Let's break it down step by step so you can see how these operations work in action. 1. Reverse a string. Question: write a Python function to reverse a given string. Example: for the input string hello, the output should be reverse of hello. The reverse underscore string function is designed to reverse any given string using Python's link feature. In this function, the argument s is the string we want to reverse. The key part of the function is the slicing operations. 1. Here's how it works. The slice notation: 1 means start from the end of the string and step backwards by 1 character until the beginning. So if we pass the string hello to this function, it essentially starts from the last character or then moves to L and continues until it reaches the first character H, effectively reversing the string. After reversing, the function returns the reverse string, which is then printed. When the string hello is passed to the function, it prints ole. This method of reversing a string using slicing is concise, efficient, and takes advantage of Python's powerful built-in capabilities. 2. Check if a string is a palindrome. Question: write a Python function to check if a given string is a palindrome. Example: for the input string radar, the output should be true. For the input string hello, the output should be false. This underscore palindrome function is designed to check whether a given string is a palindrome, meaning it reads the same forwards and backwards. In the function, the string s is compared to its reversed version, which is achieved using the slicing techniques. 1. Here's how it works. The slicing operation is: 1 creates a new string by starting at the end of the original string and moving backwards 1 character at a time, effectively reversing the string. The function then checks if the original string s is equal to this reversed version. If they are the same, the function returns true, meaning the string is a palindrome. If they are different, it returns false, indicating the string is not a palindrome. For example, when the function is called with the string radar, the reverse string is also radar, so the function returns true, confirming it's a palindrome. However, for the string hello, the reversed version is ole, which is different from hello, so the function returns false. This simple and efficient method takes advantage of Python's slicing ability to quickly check if a string is a palindrome. 3. Count the occurrences of each character in a string. Question: write a Python function to count the number of occurrences of each character in a string. Example: for the input string hello, the output should be H1, E1, L2, O1. The count underscore characters function is designed to count the occurrences of each character in a given string and return the results as a dictionary. It makes use of Python's collections.counter, which is a specialized container for counting hashable objects like characters in a string. Here's how the function works. When you pass a string s to the function, counters creates an object where each unique character in the string and the number of times that character appears is stored as the corresponding value. For example, with the input hello, the counter object will contain 1 E1 L2 O1, meaning she appears once, E once, L twice, and O once. Since counter returns a dictionary-like object, the function converts it into a standard dictionary using the dict function before returning the result. This ensures that the output is in the regular dictionary format that most Python developers are familiar with. For example, when calling count underscore characters hello, the output is H1E1 L2O1, giving a clear breakdown of how many times each character appears in the string. This method is both simple and efficient for counting characters in any string. 4. Find the first non-repeating character in a string. Question: write a Python function to find the first non-repeating character in a string. Example: for the input string Swiss, the output should be W. The first underscore non underscore repeating underscore char function is designed to find and return the first non-repeating character in a given string. The function achieves this by using a dictionary to keep track of how many times each character appears in the string. Here's how it works. First, the function initializes an empty dictionary char underscore count. It then iterates through the string s, and for each character, it updates its count in the dictionary using char underscore count dot get char 01. This line ensures that if the character is not already in the dictionary, it is added with a count of 1. If it is already present, the count is incremented by 1. After counting the occurrences of each character, the function loops through the string a second time. During this second loop, it checks the dictionary for any character with a count of 1, meaning the character is non-repeating. Once it finds the first such character, it returns a character. If no non-repeating character is found, the function returns none. For example, when calling first underscore non underscore repeating underscore char Swiss, the function first builds the dictionary as 3w1 I1. In the second loop, it checks each character in the order of the string. It finds that div is the first character with a count of 1, so it returns div. This method is efficient and ensures that the function correctly identifies the first non-repeating character in the string. 5. Check if two strings are anagrams. Question: write a Python function to check if two strings are anagrams of each other. Example: for the input strings listen and silent, the output should be true. The r underscore anagrams function is designed to check if two strings are anagrams, meaning that they contain the same characters in the same frequency but potentially in a different order. The function does this by sorting both strings and comparing their sorted versions. Here's how it works. When two strings are passed to the function e.g. s1 and s2, it first sorts both strings using Python's built-in sorted function. Sorting arranges the characters of each string in alphabetical order. If the sorted version of both strings is identical, then the two strings are anagrams because they contain exactly the same characters in the sequence. The function returns true if the sorted strings are equal, meaning the strings are anagrams, otherwise it returns false. For example, when the strings listen and silent are passed to the function, the sorted version of both strings is EILNST, which is identical. Hence, the function returns true. In contrast, when hello and world are passed, their sorted versions are different: EHLLLOORRW for world, so the function returns false. This method is simple and effective for checking anagrams by comparing sorted characters. 6. Longest common prefix. Question: write a Python function to find the longest common prefix among an array of strings. Example: for the input list flower, flow, flight, the output should be flare. The longest underscore common underscore prefix function is designed to find the longest common prefix shared by a list of strings. It works by starting with the assumption that the entire first string in the list is the common prefix, and then it iteratively checks the other strings, reducing the prefix until it matches all the strings in the list. Here's how the function works. First, it checks if the input list star is empty. If the list is empty, it returns an empty string because there are no strings to compare. Then it initializes the prefix as the first string in the list stores 0. This string is assumed to be the longest common prefix at the start. Next, the function iterates through the rest of the strings in the list, choose one. For each string, it checks whether the current prefix matches the beginning of the string using Python starts with method. If the string doesn't start with the current prefix, the function shortens the prefix by removing the last character prefix 1 and checks again. This process continues until the prefix matches the beginning of the current string or becomes empty, at which point the function returns an empty string because there is no common prefix. After iterating through all the strings, the function returns the final value of prefix, which will be the longest common prefix shared by all the strings in the list. For example, in the case of flower, flow, flight, the function starts with flower as the initial prefix. It compares it with flow and reduces the prefix to flow, and then compares it with flight, reducing the prefix to fell. Thus, the longest common prefix is flight. 7. Find all permutations of a string. Question, write a Python function to find all permutations of a given string. Example, for the input string apps, the output should be apps, act, back, backs, gap, zap, cub. The find underscore permutations function is designed to generate all possible permutations of a given string. It makes use of the permutations function from Python's iter_tools module, which is specifically built for generating permutations of iterable data. Here's how the code works. The permutations S function takes the input string S and returns tuples that represent all possible ways to arrange the characters in S. Each tuple contains the characters in a specific order. For example, for the input string ups, the permutations function would generate tuples like A, B, C, C, B, and so on, covering all possible arrangements of the three characters. However, the tuples returned by permutations are not strings, so the code uses .join p to convert each tuple p back into a string by joining the individual characters. The list comprehension .join p for p in permutations assures that all the generated tuples are transformed into strings, and the function finally returns the list of these permutations. For example, when the input is app, the function returns up, app bika, cap, bar, which represents all possible ways the characters in app can be arranged. This function is useful for solving problems related to combinatorics where you need to explore all possible arrangements of elements. 8. Check if a string contains only digits. Question, write a Python function to check if a string contains only digits. Example, for the input string 1, 2, 3, 4, 5, the output should be true. For the input string app123, the output should be false. The contains underscore only underscore digits function is a simple utility that checks whether a given string consists entirely of numeric digits. It uses Python's built-in isDigit method, which returns true if all characters in the string are digits 0 to 9 and false otherwise. This method only works for positive integers, so it doesn't consider decimal points or negative signs as valid. When the function is called, it evaluates the string s using the isDigit method. If every character in the string is a digit, the method returns true, otherwise it returns false. For example, in the test case contains underscore only underscore digits 123 45. The function returns true because the string 1 2 3 4 5 contains only digits. In contrast, for contains underscore only underscore digits app123, the function returns false because the string contains letters in addition to digits. This function is useful in scenarios where you need to validate user input, ensuring that the input contains only numbers and no other characters. 9. Convert a string to title case. Question, write a Python function to convert a string to title case. Capitalize the first letter of each word. Example, for the input string hello world, the output should be hello world. The to underscore title underscore case function is designed to convert a given string into title case where the first letter of each word is capitalized and the remaining letters are in lowercase. It uses Python's built-in title method, which automatically processes the string and applies this transformation. Here's how the code works. The function takes a string s as input and calls the title method on it. The title method scans the string, identifies each word separated by spaces or other delimiters, and capitalizes the first letter of each word while converting all other characters to lowercase. The method then returns the transform string. In the test case to underscore title underscore case hello world, the function converts the input string hello world into hello world by capitalizing the first letters of hello and world. This function is particularly useful when formatting text to ensure proper capitalization for titles, headlines, or any input where consistent capitalization is important. 10. Remove vowels from a string. Write a Python function to remove all vowels from a given string. Example, for the input string hello world, the output should be hello world. The remove underscore vowels function is designed to remove all vowels from a given string, both lowercase and uppercase. It achieves this by iterating over each character in the input string and checking if the character is a vowel. If it is not a vowel, the character is retained, otherwise it is excluded from the final result. Here's how the code works. First, a string vowels is defined that contains all the lowercase and uppercase vowels a, u, e, I, u. The core logic of the function is a list comprehension which iterates through each character in the string s. For each character, the code checks if it is not present in the vowel string. If the character is not a vowel, it gets added to the list generated by the list comprehension. The dot join method is then used to concatenate all non-vowel characters into a single string. For example, when the input is hello world, the function iterates through each character in the string. It removes the vowels e, o, and joins the remaining characters h, l, var, l, d into the final string hello world. This approach ensures that all vowels are removed while preserving the original order of the remaining characters. The function is useful in scenarios where you want to filter out vowels from text for specific formatting or analysis purposes. That's it for today's video on Python string operations. I hope these examples gave you a better understanding of how to handle string manipulation in interviews. Remember, mastering these basics can give you a solid edge during technical rounds. If you found this video helpful, don't forget to hit the like button, share it with others, and subscribe to the channel for interview tips and coding tutorials. Thanks for watching, and I'll see you in the next video.